So thank you everybody to be here for this various session of the HPM seminar of this year. We will listen from Andrei Rodin from the Archives Henri Poincaré or Nancy. The presentation will be on Proclus, on Euclid's definition of plane angle and the concept of mathematical structure according to Voevodsky.
Yeah.
So
thank you, Rodin. Thank you very much for inviting me. So this work is a tribute to memory of Vladimir Volodya Voevodsky, who died in September 2017, just after turning his 50s. And actually part of my effort to build his legacy, not only in pure mathematics, but also in philosophy. So the big plan, I try to be short, took rises. This is his vision, Vladimir's idea, explained in a couple of words. And actually this talk is based on our correspondence, actually just a little part of it, where he sent me a message where he actually made a suggestion about Proclus. He was interested in Euclid Proclus, and for that matters actually we communicated. I asked him more, explain me there were complicated mathematics. He asked me to tell him something about Euclid and some other historical matters. And then he also put forward very interesting idea and very unusual, what is mathematical structure. So second point, I'll just show this fragment of correspondence, and then the most part of the talk, I'll try to explain what he meant. I did not understand that immediately, but then I think I really understood, and I think it's really interesting. And then actually I reconstruct this Proclus argument because it's also interesting, I think, by itself. And this Vladimir suggestion, looking into it a little bit from this point of view of homotopy type theory, when he didn't say that explicitly, but that was clearly implicit, I think sheds interesting light to that argument. And then I come back to some generalities, say a couple of words about structuralism, and finish with some open problems and probably program for research. Right. So Vladimir Voevodsky publicly is best known for his Fields Medal received in 2002. And here I just quote for what he received that. He made one of the most outstanding advances in algebraic geometry in the past few decades by developing new cohomology theories for algebraic varieties. This achievement has its roots in the work of Alexander Grothendieck, and that's indeed for Vladimir was the main reference in all his work. And the major advance, it's a quotation which I continue from notes of American Mathematical Society, just explaining his Fields Medal. Major advance came when Voevodsky, building a little understood idea proposed earlier by Andrei Suslin, created a theory of motivic homology. One consequence it's Andrei Suslin. Yeah, he was he died rather early. That was recent. That was contemporary. Okay. And so one maybe best known result, which actually was a consequence of this work, was so-called Milnor conjecture in algebraic K-theory that he proved. And actually, that result has striking consequences in several areas, including Galois cohomology theory, quadratic forms, cohomology of complex algebraic varieties. And I add that in 2009, Voevodsky, actually, again, that was published, proved the so-called Bloch-Kato conjecture that is a generalization of Milnor conjecture. And I mostly quote this for some keywords. I'm not the best person, obviously, to explain that, and I'm not going to do that. But I want to contrast it, because here I quote is from interview of Vladimir that he gave to his friend Roman Mikhailov, also mathematician, was in Russian. It's still on internet somewhere. I translated it into English. So this part of interview where Vladimir somehow provides a narrative about his, scientific biography. So he says, in fall 1997, so it's 5 years before Fields Medal, and how many? 12 years, right? Before Kato conjecture, he said, I realized my main contribution into motif theory and motif homology was already accomplished. Since then, I was very consciously and actively looking for a theme to work on. So you see, he actually was, in a sense, untypical mathematician. He never did, for example, the special mathematical schools, which are, at least in Russia, mostly produce Fields medalists. His interests were rather much broader, scientific. So mathematics, he came that separate story. I don't have time to talk about that, but he didn't see this work as a kind of most important, subjectively, even probably objectively it was. So he said, considering tendencies in development of mathematics as a science, I realized, Vladimir says, that mathematics is the age of crisis, more precisely, two crises. First crisis concerns the gap between pure and applied mathematics. It is clear, said Vladimir, that sooner or later there will arise a question of why the society should pay money to people who occupy themselves with things having no practical application. So he was really concerned about that. He was not at all in this, as many other people, even in the Moscow mathematical department. He was not driven by the idea of pure mathematics as a kind of, self-sustaining. He didn't believe it, that it could be self-sustaining, right? And the second crisis, which is less evident, concerns the fact that mathematics becomes very complex. As a consequence, once again, sooner or later, mathematical papers will become too difficult for detailed checking, and there will begin the process of accumulation of errors. I decided to do something to prevent this crisis. In the first case, that meant to find an applied task. So he actually tried to do that practically rather than philosophically, of course, just to have a good example, to create a good example. So he tried to find a applied task which would require for its solution methods of pure mathematics developed during the last years, or at least during the last decades. I was looking for open problems which would be interesting for me, where I could apply today mathematics. Finally, I chose, and now understand wrongly, the problem of reconstruction of history of populations, meaning living organisms or humans, right, on the basis of their present genetic. So his idea was just having, the genetic data for today, somehow make a mathematical model which what could be possible past for that given, something of that sort. I worked on this problem about 2 years and finally realized in 2009 that everything that I invented was useless. That was the greatest scientific failure in my life. A great amount of work was invested into a project that failed completely. That's how he says that. And that separate story, which I just gave him for context, I have a paper on that, and I think that he really has interesting idea how, and that special discussion, and just for announcement and for the context today, I may present another time, if you like that. And that's something I think it's really worth to be developed. But then continues the interview. During the same time, I was looking for an approach to the problem of accumulation of errors in works of pure mathematics. It was clear to me that the only solution was to create a language with the help of which people can write mathematical proofs checkable with computer. And until 2005, this latter task seemed to me more difficult. But in 2005, I managed to formulate several ideas which unexpectedly opened the possibility of new approach to one of the most important problems mathematics. That, of course, is better known. That's what became known as Univalent Foundation. Later was organized by Vladimir, that so-called homotopy type theory year in Institute of Advanced Studies, where he was appointed a permanent professor. But here it's also something important. So you have in preface of that book that some people here certainly know, there is his name, but as a matter of fact, and that's something he told me, and actually many people, he did not take part in this work at all. He was still probably in crisis, probably because of this failure of his other project. So he did not contribute at all. He told me that he actually wanted to withdraw his name from that book because somehow he did not approve at all on that outcome. He wanted something very different. No, anyway, that just says that, say, philosophically, you see, he had some ideas. He was not just, alien to any general reasoning, but his idea was completely orthogonal to ideas of these authors of that book, right? Even then, again, there's some, not all of those authors, but some at least, right, were kind of philosophically engaged and interesting, and so they also, some of the same authors, like Steve Audi, for example, they published some philosophical papers about that, but all of this has nothing to do how Vladimir would see it himself. And that's why I think it's interesting and important to try to reconstruct it. Okay. Yeah, so that is just timeline. Sorry for my scrambles. So here it's his work in algebraic geometry, which continued roughly until 2010. That's this, unfinished, I will say, failed project, and that's his work on Univalent foundations, which continued until the end of his life.
What is 2003 Wuhan lectures?
Yeah, that's because when he was given this, that's interesting story, because he was given this field medal actually by then the president of China, but you should know the name before this one, right? So he was invited to China, and after that trip in China, he gave actually 2 talks. One in Wuhan in China, right? Another in that's in India. He also traveled to India, and then also he gave. And actually, this general idea, I don't know why he never publicly presented later, say in United States in this western part of the world. That's, I don't know how to explain that, but actually. His mostly systematic public talks about these philosophical matters, he gave them that early in 2002, just after receiving field at these occasions. Yeah. Now I come to our correspondence. Okay, that's late. It's 2014. Okay, we exchange mails, not different issues. That's my translation. We exchange in Russian, of course. So he writes, in Proclus, we find a clear distinction between a property and a structure. See his reflection, Proclus' reflection, on how to define an angle in his commentary on Euclid. Then Vladimir comes. Relation is a joint property of 2 or more objects. That's clear, right? In philosophy and mathematical logic, the model of the world is based on a collection of objects and a collection of relations between these objects. That is a collection of properties of assemblies of objects. Okay, I wonder, so he asked me historical question, which I still don't know the answer, and that I will come to the very end of this talk. When and how there emerged the strange idea that the foundation of the world, can be described with a collection of relations between objects rather than with a collection of joint structures of on assemblies of objects. There should be a historical moment when this idea first presented as auxiliary simplification, as if something says, my words, let's assume this laughably simplified version of the problem, just like mathematicians often consider simplified version of a problem in order to test with it some general idea. Right. So first, frankly, I did not understand. Probably you, yeah. Then he gave me postscriptum. He says relation either holds or doesn't hold. Straight lines are either parallel or not, but the structure can have more than one representative. So first, I did not understand what really he's talking about at all. And right. So I replied something I think stupid, and I just saying, since he referred to relation, I think he understood in kind of usual way. So that was my point where I could pretend to to reply him, give some historical. So I say, in my understanding, this idea first emerged in logic in Frege, and later Russell designed for this logic appropriate ontology. So what I meant is introduction to Russell, philosophy of logical atomism, where he says exactly that. So I invent ontology for logic. So logic comes first, then comes ontology. But then I'm asking, could you clarify what you call a structure? If it's not a collection of relation, then what it is? Because when he opposes structure relation, looks strange, right? We say, okay, something like set with relation is a structure. How you kind of, yeah, but that's not, you see how he thinks about structure. So Volodya replies kind of officially, a structure on several objects is an entity that links these objects in a number of different ways. A relation between two given objects either holds or does not hold. That is, either there is a link between these objects or not. So the set of possible versions of this link is either empty or has one element. A structure is a link that the set of its possible version can have more than one element. No, now I understood actually. He meant yeah, and I'll try to explain. Yeah, I try to explain. Notice that definition structure, a relation is a special kind of structure. Yeah, but then also maybe it's not. Again, I come to that. Again, he did this historical comment that I first didn't take seriously, but after reflection, now I tend to take it more seriously, because he said he says, I doubt the idea to use relation instead of general structure first appeared in logic. Look at Hermann Lotz's metaphysics. How I did not kind of advise him to. Somehow he picked up on lots of metaphysics. In the first 100 pages, he discusses world picture based on a set of objects and relations. By the way, Boole's work also finds objects. Perhaps Boole provides a reference pointing source, but I doubt that Lotz read Frege. By the way, he was wrong. Lotz certainly read Boole. But I don't know if Lotz ever read his pupil Frege. That's I did not find. No, anyway, that will be in the very end. But now let me try to explain actually what is that's the main part of this talk. So first, Euclid's definition from the element. A plane angle is the inclination, is the translation standard by his of the lines when two lines in a plane meet one another and are not laid down straight on with respect to one another. So straight angle, as it's called in schools, is not angle in Euclid's sense. Okay. Yeah. Just couple of preliminary remark about this definition, right? First, it followed by another definition, which is of a rectilinear angle, because that definition I just read, this sides can be curves rather than straight lines, right? Then it's next definition 1.9 that just specifies that for a rectilinear angle, right? Yes, that I said. Then actually in book 11, there are much more kind of angle related definitions like angle between two planes, solid angle, but there is no angle, say, on a sphere, like spherical triangle. And that is going to be something like that Proclus example. It's not found in Euclid even. No, that's just preliminary. And yeah, so how now to Proclus? What he wants to do in his commentary is classify Euclid's definition, but actually Proclus there, he does not stick to Euclid. You know, he just talks about anything related to defining an angle. So he takes a lot of sources, so he does not stick to Euclid text, at least maybe. Yes, but this was my impression. Yeah, he bring probably everything he knows about this matter, right? So his idea was to classify what is an angle according to Aristotelian 10 categories, right? That he considers three: relation, quality, quantity, right? Meaning relation, that's exactly what, at least he takes it that way, I think, correctly, what they find in Euclid. So it's relation of inclination, whatever it may mean. Quality is something saying that figure is some special kind of figure, like circle, whatever, right? And quantity meaning it's measurable quantity. So there is bigger and smaller angles. But I'm not going actually to look into this whole Proclus commentary, just this part which is relevant. In conclusion, Proclus is kind of synthetic. He kind of says it's all at the same time. So I will not try my talk about this whole commentary, but just on a part which is the following. Yeah, which is the following. This is quote from Morrow's translation of Proclus. So he says, if the angle is an inclination, and in general belongs to the class of relations, just only very little remark. Of course, I'm not entering what relation is in Aristotle is not quite probably the same as in Frege, but only one thing. Of course, for Aristotle defines what we would call relata, right? It's not relation in some abstract sense, is a kind of ontological distinction. So here, probably you would better even translate if belong to the class of relata rather than class of relation. Anyway, it will follow that when the inclination is one, there is one angle and no more. For if the angle is nothing other than a relation between lines or between planes, how could there be one relation but many angles? Okay? That's Proclus. If you imagine, but now the kind of second part of the argument, his argument. If you imagine a cone cut by a triangle from apex to base, you will see one inclination at the apex of the half cone, that of the sides of the angle, but two separate angles. One the angle of the plane of the triangle, the other mixed surface. I'll explain what I mean mixed on the cone. And both of these angles are contained by the above mentioned two lines. The relation of this line then did not make the angle. Okay, yeah, that's the cone. So what he wants to say, we have like the same lines, straight lines, right? A, O, and B, O, and we have one angle making part of just triangle of a plane triangle, A, O, B, right? And the other angle, which is on conic surface. You see, so it's bounded by the same lines, it has the same vertex, but first angle is just plane angle, and second angle is this, I don't know, not curvilinear, but curved surface. But you see, right? Is it
You mean the arc?
Yes, yeah. So actually there are three given angles, right? Because there is the other way symmetrical. So this is a part of conic. Actually, it's half of conic surface. Okay, that is the second angle, and on that basis, Proclus says it's not a relation. I'll come back. Actually, it's interesting why it's not a relation because there are two angles. It's not straightforward. But I come just a little bit. At first, I point to analogy with homotopy type theory. That Vladimir, in my understanding, I don't think I can be wrong here, had in mind, right? So in Vladimir's term, he would say angle is a structure here, right? It's not a relation, it's a structure in his sense of the word structure in this construction. Yeah, it was structure is an entity that links these objects, and objects are these sides, right? AO, BO, and that there are two links, two different angles, they link them. What make it structure is in Vladimir sense. Yeah, and actually in homotopy type theory, of course, I would spend all my time if I try to, make introduction now. But the idea is actually the same. If we take this identity types, think about identity relation, if you like, right? Which is actually more than just an example, it's kind of generic example for homotopy type theory. But if you think about equality as a relation first, right? Either A equal, I say equal identity, it's interchangeable now, right? A equal to B or not, right? You don't have. But in homotopy type theory, you may have more than that, right? So you have this type, because proposition is a type, and actually you compare terms A and B, which should actually be of the same type C, otherwise in this theory things cannot be identical or not identical, just ill-formed expression, unlike say set theory, right? Where you can always say set is the same or not the same because it's not typed, and this is a theory which is typed, right? But the idea then that you may have like two different evidence. This is a constructive theory, so it's not just something is true or false, but you need the evidence, which you may think about as a proof. Sometimes people also use the word witness, right? And suppose you have two different evidences, and then of course you may just form a type of these evidences, right? And again, ask, is it two evidences actually the same evidences or not the same? And thus you have this complicated structure, which actually is modeled by homotopy theory. That's the whole thing of homotopy type theory. Here is kind of physical example, perhaps pseudo-physical, of gravitational lensing around a wormhole. Some people really believe now that some centers of galaxies are not massive black holes, but wormholes, which means, a hole in the space-time. Anyway, it gives the same effect of gravitational lensing. So if you want kind of identify image in your eye and say a star, say this is the star, right? You have instead of one, light ray, you have two. Well, of course, actually, you may have something like that even classically, it's some mirrors or something. It's just a fancy way to talk. Right, and actually you see two sources, which are actually the same source because of this lensing. And that's the idea that you not just have something which is the same or not the same, right? But you have different two ways of being the same, and that makes real physical consequences and perceptive consequences, I feel like. Yeah, so now let me go back to Proclus' argument, and actually, for those of you who never heard about homotopy theory, I think that can be introduction via Proclus and Euclid. So at least it has this pedagogical value, I think. So Yeah, just one remark. Of course, such angles of the kind of that Proclus brings into his argument, right? Which is a curved angle in the sense that it's on curved surface and not plane angle. They are not in Euclid. So you may say, okay, that's just irrelevant to Euclid, but I just said it's not important for for Proclus. Of course, it should work somehow, not just in the elements, but in principle. Right. So that's yeah. So you yeah. So what is the about the argument? What is wrong to have we have a definition and we have like two objects which fall under this definition other one. What is wrong about that? Right? Because of course, if we give some definitions, we have a lot of examples of concepts which may be instantiated some infinite classes like triangles. There are some with a single like empty set, right? We may prove there is just one empty set. And then, of course, there is empty extension, which is kind of meaningful. If you say the largest prime, sounds, how to say, as a meaningful concept, right? Even if with a little proof, we show that it's actually nonsense. It cannot exist, right? So, just for saying that extension of a defined concept is not an issue, is not relevant for saying that definition is good or bad. Okay, so it's not about extension, but what is about what? And so I propose the following reconstruction that actually what Proclus has in mind, he takes this assumption, no, that's my reconstruction, right? My claim, which is the following, that an instance of binary relation, well, that I put for this Euclid's inclination, is fully identified when relata are identified. So you have two lines identified. Of course, that can be problematized, right? How lines identified, we leave it now aside. Just if we take lines as individual, then this instance of relation is also when well identified. And basically that means that we have a notion of pair. And since we have a symmetric relation like that one itself is a symmetric, this inclination, right? Then actually we may justify it with set theory, but interestingly, if we want ordered pair, right? Just talk about relations in general, then actually we encounter this Benacerraf like problem because there are many ways to encode ordered pair in a set theory, and there is no one canonical way. So this is just kind of popular Hausdorff for Voevodsky. You can do that in infinite. Yeah, so it's kind of interesting, but probably irrelevant to my talk. Just remark. Yeah. So what is the argument according Proclus' argument? How I reconstruct that? So we assume that these two lines are well identified. Then we assume this principle, relational uniqueness, however, right? And then, yeah, and then you show that actually this principle you violated because you have two angles, right? So, first you assume that your angle is just this pair of lines, so and so related, right? But then you say, look, not. I have the same lines, right? And two different angles. So that would violate this principle, which I call relational uniqueness, to assume that angle is a pair of lines, right? That's so we conclude that angle is something else. Right. No, so it's transparent, I think, this reconstruction, but actually I'm going to propose another one, which probably closer to what Vladimir had in mind, maybe also more illuminating somehow. Because here we just say, okay, look, it's just a pair of lines. So what Proclus wants to say, according to this I call it classical reconstruction, is that you cannot identify angle with a pair of lines, however related. That's what he says, because that would that doesn't work with this identity principle, right? How you identify pairs on the basis of its elements. Right, but here is kind of constructive reconstruction. And in construction, just very short generalities about validity of judgment, truth of proposition. I follow Martin Löw here. So that is a proposition, right? Or so proposition, something having truth value, but to make a judgment, and in this constructive theory, it's two things are really distinguished, is to give a proof, right? So you need a proof of this, something that proves it, and as a proof, I take this very angle, right? In that case, yeah, it makes the definition kind of circular, but we may talk about it, but I think it's not really important. I think most of Euclidean definitions are circular. Yeah. But now to support the argument, we should actually make assumption which may look strange, but on the other hand, it's exactly how things are done in homotopy type theory. So you should assume that proposition, in particular this form, right, that expresses that certain two individuals hold some relation R, has at most one proof or one witness, which of course kind of intuitive, because you may say how we know that there could be many proofs for one proposition, right? But then it actually makes sense to think what we call indeed a proposition, right? And at least in this constructive logic in homotopy type theory, the idea is to distinguish between proposition in this hot book, it's called mere proposition, right? As an entity which satisfies that requirement, that exactly it has at most one proof, which is kind of analog of classical truth value, right? So you say, okay, something like Pythagorean theorem, there are hundreds of proof, but I just thinking about it, it's kind of abstraction from its proof, which generally below that philosophy of constructive logic is not really allowed, right? Because somewhere Martin Löw says, for example, things like proof gives a meaning to proposition, right? But here you have kind of reduced proof. You just, or probably a label of proof, right? So you just want to say that proof exists, and you don't want to specify which proof, and you don't want to distinguish between these proofs, right? Right. That's related, probably I skip it because I have time, to what is called homotopical hierarchy of types. So that's actually a feature in homotopy theory. It's very nicely modeled by different, kind of homotopy spaces, but probably I just skip that. Yeah, and I just want to sorry. Yeah, and that's just reconstruction, the second reconstruction, right? So we assume again that lines are identified. We assume this constructive version of relational uniqueness. Then we assume that since it's a relation, it's a proposition, should be just one witness, and we have two witnesses. So once again, it's not a relation and not a proposition, but as Vladimir says, a structure. Okay, and now I just want kind of mimicking Proclus gives a modern example. Apply similar argument to something which is more modern. Question is isomorphism a relation or not? Is it isomorphism a relation? And using similar argument, you say, no, it's not a relation because, say, given two groups, for example, you can point two different isomorphisms. Right? That's, I think, exactly the same argument that Proclus uses. So it's not a relation, I say it's a map, or if we go to, higher order algebra, I would say high dimensional cell. That probably I will not go into that really. But then, of course, you say you can define a relation, right? If you have this notion of isomorphism as a map, you say relation holds just as such map exists, right? And then you may call this isomorphism as a relation, as a truncated version using terminology of homotopy type theory of relation as a map or high dimensional cell, because it kind of forgets a lot of information about different isomorphisms, just witnesses the fact that at least one isomorphism exists, and completely forgets all that structure of isomorphisms. Okay, and the same actually interesting in a constructive setting, because now that was not constructive reasoning, but constructive setting, suppose that we have a algorithm which calculates for two groups, which builds effectively isomorphism or proves that it does exist. By the way, well known that in general it's provably uncomputable. It's rather famous results of 50s by Novikov and the late Adyan. But okay, you can do that in some special cases of well-behaved, presentable, finitely presentable, obviously, groups, right? And then, of course, you may argue, look, if my notion of relation, right, I have behind an algorithm which builds isomorphism as a map, is it somehow conveys me the whole meaning of what isomorphism is after all, right? If I have effective procedure. And actually, I think the answer is still no, but reason is interesting. And reason is that, okay, you can constructively produce isomorphism as a map, which comes along with your relation in this constructive setting, but you cannot still distinguish between different isomorphisms. So you kind of violate this requirement of no entity without identity. So you cannot, it's still a not well-defined object, even if kind of constructively given. Right, and now already coming to conclusion. So I'm trying to kind of compare this idea of structure that Volodya put forward, of course, on the basis, as we see, right, on homotopy type theory, but I think he found a kind of nice illustration, at least, of this notion in Proclus, how it compares with kind of standard understanding mathematical structure. But of course, there are a lot of different, but I take it as a kind of common feature, as far as I understand, right? That structure is something which satisfies this principle or axiom. Isomorphic structures are identical, right? Always. Whatever differences, there are many this version of structuralism, but I think they all submit under that. Yeah, then as already mentioned occasionally, bits of stress that actually that is not compatible with set theoretic foundations normally, right? That's interesting. Yeah, that's Dieudonné actually himself already didn't like set. That's interesting. That's kind of beginning of more or less Bourbaki, and he already talks about kind of eliminating sets, because sets is something they, or at least he didn't like, actually. Yeah, and interesting, of course, one foundation, in a sense, accomplished that program, right? Because they really, and that's argued by many people, I think quite correctly, that indeed, in this framework, you can give a precise sense in which isomorphic, types, structures, you may call it, or you call them identical, right? And that's basically you're just reading univalent axiom in that way, of course, losing 90% of its real meaning. But anyway, that's kind of fair description of univalence axiom. Yeah, and actually Vladimir, it's some talks he mentioned this idea, right, to accomplish this structuralism. Probably he did not talk about structuralism, he would talk about the just principle that I want to have this isomorphic group identicals. He mentioned as a motivation behind his project, but it was not a kind of major motivation. He had this official lecture he gave in the Institute of Advanced Studies, which was later published, titled Motivations of Univalent, and he does not mention that at all. Right? So what I want to say that, yeah, it's part of already my conclusion. So this is a very rough picture of history of structuralism, very, very rough, which starts with novel ways of reasoning, saying Grassmann, Piana, Dedekind, Hilbert, right, noticed by some sensitive philosophers, like I would put in first place Terence Cassirer, maybe Russell also, Frege, but I think Cassirer was really sensitive, say what Dedekind was doing. All right. Then came this big reconstruction idea, which was not philosophical project, was rather mathematical project, right? To rebuild mathematics on that notion of structure, which was not maybe fully successful exactly this Benazirov kind of thing, because after all, we see set theoretic foundations simply incompatible. They do not allow to realize it. Structural is idea precisely, right, that was stressed by Benazirov. But then later in, say, 80s, I would call it sedimentation. So there was a lot of people we well know, like Michael Resnick, Stuart Shapiro, Geoffrey Hellman, Charles Pratt, and many others, right, who tried to build this structuralism as a timeless doctrine. They no longer actually refer to any mathematics of any particular time, but as a matter of course, they kind of, how say, try to eternalize to some patterns emerged in the beginning of 20th century. And then indeed, with Univalent Foundation, you have kind of accomplishment because in a sense, it solves the problem, really solves the Benazirov problem, mathematically, let me say. But I think that it just analyzing, say, Univalent Foundation in this optics, structuralism, right, which comes from ideas beginning of 20th century, we are just missing what is really new and interesting. Yeah. It's kind of you know, dialectical. We have this accomplishment, but we have a lot of new interesting things which we apply this you know, old optics. We simply miss. It somehow works more or less, right? But we simply miss what is really new and interesting in this theory. And I think today we should be follow Cassirer Russell, not in the sense that taking their, how say, conclusion as kind of dogmas, right? But rather in a methodology, right? Be really sensitive to mathematics today and recent, right? Like those people were 100 years ago. Yeah, I had this paper actually before I really learned about Univalent foundations, where I tried to apply similar to category theory. So I took this category theoretic structuralism again as kind of new wine into old bottles and try to develop non-structuralist theory without coming back, so to speak, right, to some substances or something, but really, and actually, key point of my critique was that isomorphism is a map, first of all, or today we may say high-dimensional cell and not a relation. And another issue which actually goes beyond the standard homotopy type theory is invertibility, right? Because we want general category theory, and that was very much message of Grothendieck that we should treat all morphism on equal footing and not distinguishing isomorphism in this special sense. And that's something that still remains to be done, probably in so-called directed type theory that I talked here in another occasion. Right. Yes. Now, final points concerning historical question, Vladimir, right? So here indeed we have, I think, a large room for studies, right? And I think we really should not stick to this standard views which originate from mathematics of beginning of 20th century, however interesting and important they are. In 100 years, really a lot of things happened. And I think as philosophers, we really should digest all of that. And that's a lot of work. But to historical question, right? He asked me where it happened, when this kind of big fall in history, when people forgot about structure and for some reason took to a relation. Here I just repeat for reminding you his works. But I think one thing that I did not first realize, that Lotz looks like indeed the key author. At least I don't know if you know about this discussion between Hans Sluga and Michael Dammit, right? No, that's really interesting because Dammit, I think everybody knows, right? His interpretation of Frege, and Sluga, actually German philosopher, but who spent most of his career in Stanford, Berkeley, California. Anyway, so he argued for historical view on Frege. He says, okay, no, actually, Dammit was kind of systematically anti-historical. He said, okay, forget your history. Ideally, I'm not interested in that, right? I just want to be philosopher. And Sluga argued that it's kind of naively wrong, of course. And actually, he argued, he was one of these initiators of this trend, which is now, I think, developing kind of history of analytic philosophy, right? Because when the times goes on, you can't say, I'm not interested in history. Okay, you won't forget your, how say, damn past, Soviet rhetoric we used to say, but still your own past somehow becomes significant. And actually, Sluga also shows how Frege's idea come from Lotze, among others, probably, according to him at least, it's the most important author for understanding Frege and the genius, historically, and genesis of his idea. Now, yeah, okay, on Bull I probably skip. And now probably what Vladimir proposed, I'm still not convinced that we should rewrite everything we are talking about structuralism and history, right? Because, okay, if we somehow prescribe structuralism to Euclid, I think we are risking to just to lose any orientation. But as far as the history of relations, concept of relation concerns, I think that can be interesting, right? For example, in Leibniz, right? David did a lot for kind of projecting this today homotopy theory on Leibniz, which apparently makes sense. And so we should probably look more precisely what, say, Leibniz meant by relation, right? Whether or not it might resemble what Volodya would like to call a structure, right? And right, and I think it's interesting project. Last thing, I actually skipped a bit. I forgot to say what was Vladimir's motivation between this behind this distinction, relation versus structure. Of course, he wanted something he would call mathematic beyond set theoretic level, right? So he would see all of that as a project of kind of going beyond Bourbaki, not in the sense of how say, this Bourbaki style mathematics, Because what he did in algebraic geometry, like motif theory, according to him, actually did not belong there, right? And so was found rather on that higher dimension in this higher dimensional algebra, which, by the way, does not mean you cannot reduce things. Of course, you can describe what is a groupoid, saying is a kind of multigraph, and you add operation. So of course you can all express in standard means, but probably you shouldn't, right? Interesting point here that you should do that. And you should explore that different way of organizing mathematical reasoning. Yeah, thank you.
So thank you very much, Andrei. We have 5-10 minutes for question and answer. If there is someone online.
Thank you very much. I learned a lot. I have one question. I understand that the point was to interpret what Proclus said with respect to algol. No,
With respect to
to algol. To
Algol.
I'm sorry, my nose is
yeah, me too.
However, how do you interpret what in this context would be done with angle as a structure, as opposed to angle as a relation? What, in the context of geometry in the tradition of Euclid, would be done with angle as a structure?
No, one thing I can repeat what I think I said already, right? That's what Vladimir really meant, and that's really analogous.
No, but I understand, but this is an interpretation
Yes, of course.
of a discussion
Yes,
about
yes,
angle.
yes.
And now I'm interested in, besides the definition, what does this tell us besides the definition? What does this tell us
About angles.
about mathematical practice?
No, one kind of lazy way to answer your question, right? Would be that this notion of structure, which came into the fore only with homotopy type theory, right? Kind of always was there and somehow was working.
Yeah, especially.
Yeah, that's lazy. That's lazy. Yeah, I agree. But
But you see, I mean, my point is, you can cast light on an interpretation of the definition. However, how does this shed light on what actors at the time did with angles?
Well, actually, there are much more examples. It's very rich, this commentary of which I took only small part. And he gives a lot of interesting examples, which are from today's point of view, mathematically interesting, I think, right? Without curved lines, which,
Sure.
yeah. And so that was somehow in practice, we should look in which part, right? Because I think Proclus has behind him like several centuries at least, right? Of mathematics of different sources, right? But it was not codified in any definition, I think, right? And that's work that in the 5th century Proclus is doing. He compares available definitions, not only Euclid, he was another, available and compares with practice. And actually what he finds that there is mismatch. So finally he can only make kind of very dialectical considers that it all at the same time. So in a sense, he makes it clear, I think, that practice is richer, much richer than any definitions. There are many cases. Here he's kind of really critical, almost skeptical, like Sextus. He says, okay, that's definition, you see, but now I kind of deconstruct it completely. And
Thank you.
yeah, thank you.
Okay, so this is a very vague question because I'm not an expert in this, but I wondered what's the role of the didactic act, what's the role of pointing to something? So if I have a diagram, I refer to an angle, I point to it, right? And you clearly see that he frequently refers to diagram.
Yeah.
You see like look there, right? He's like showing you. And I would look at that as a like a give you witness, right?
Yeah, yeah,
So I wonder what the role of that would be.
yeah,
For example, when I talk to the when I talk about isomorphisms, I kind of rely on a and I want to talk it in the terms of structure, which you try to just then I rely on like a classification of groups which has taken place in order to say, okay, look at that. You can like find a witness for those. So I wonder what that.
yeah, thank you.
what you think.
I think it's, I was thinking about that question, just decided not to talk about that. Yeah, thank you. I think it's an important question because it indeed, at least, let's talk about rather Engels and Proclus. It only makes sense, his argument, if you have this ostensive way to identify an angle, right? So your angle is not something that you learn from definition. Somehow you learn it intuitively from whatever, right? So you may say that is an angle even before you have any definition. You say that's an angle and look, it doesn't fit your definition. And that's indeed something, how to say, fundamental in yeah, for isomorphism, but I think it's similar in a sense, right? You may the standard notion of isomorphism actually does allow, no, at least modern notion, right? Kind of sets, if you construct it set theoretically, you can explain easily, right? What are two different isomorphisms? All right.
Do you think that the structure captures this ostensive?
No, what I think that this notion of structure, right? It kind of ignores this richness which comes with acknowledging of pluralities or isomorphism, because it's not interesting. We say we only interested it exists or doesn't exist, which you may make moves like that, right? But in that way, you just forget a lot of structure. You see?
Yeah, I just wanted to know if what would be the alternative conceptual framework if structuralism is not the good one to understand thought.
Yeah, that's for another talk. Yeah, yes. No, kind of intuition. No, there are two. One that I just said, right? We should not just stick to relation, but we have all this high demand. And second thing is about invertibility. All right, that actually, if you take all morphism somehow seriously, right, you have no longer this preference to distinguish isomorphism as something very special and which constitutes, in a sense, your objects of your study, right? You should study all, which is not realized in standard thought, because then also in this paper that I mentioned about motivation of Unival Foundation, which published on the site of Institute of Advanced Studies, he says that he first tried to do that, following Grothendieck, right? Just to make general category theory into foundation. But then somehow he realized that it would work better just if you restrict to groupoids. Yeah, and I don't see kind of a principal argument, right? And I personally believe it's still interesting and possible program to generalize, say, hot to non-invertible situation, which is known as directed actually. So I'm kind of hopeful for that. Mhm.
Well, I had just a follow-up on your question. That is, what is happening in that passage of Proclus, I think, is that he is comparing the definition of angles as relations and the definition of angles as magnitude. And this definition of angle as magnitude was probably given by Apollonius, and this meant that you consider an angle actually as the surface intercepted by the size of the angle. That is not just a relation, but some kind of plane surfaces. And I think that Apollonius' point was that someone said, well, but it is the same thing. For you have an angle and you have that part of the plane which is intercepted by the angle. So the two things are, let's say, isomorphic in this sense. Relations corresponds one-on-one to surfaces, sectional surfaces. And Apollonius' point, here reported by Proclus, is that no, or given an angle and two lines, you have one relation, but many possible different surfaces if you consider also the surface of the cone, etc. So there is no correspondence between, say, the set of relations and the set of magnitudes as far as angles are concerned. And in mathematical practice, this may change, of course, because you may want to measure the angle of the cone in a different way than the plane angle of the triangle.
I think this opens to all the practices with angles. I'm thinking of Ptolemy, for instance,
Yes.
which is something that is completely different. So there are all kinds of practices with angles, which would be interesting to explore further, because I think really that we have lots of questions about angles that would be interesting to go deeper into. Perhaps an idea for next year.
Actually, when I tried to read all of this commentary, not only that fragment, I got the impression that you start to question whether this intuition, we have this kind of intuition, probably it's educated, I don't know, right? What angle kind of really is, right? But then when you just go through all those examples that Proclus provides, you think probably it's kind of misleading in the sense that there is no single concept behind what we kind of call conventionally an angle, because there are such many different.
Yeah, in fact, all of a sudden I remember that Guillaume Wesley, who has worked on Arabic authors who followed in the footsteps of Ptolemy, has lots of things to say about angles and magnitudes. In the Arabic world, because there is a conceptual work on this issue that would be interesting to add to this discussion.
So, thank you.
There is no.
No online, there's not.
Mm.
So thank you.
Thank you.